be fair, I asked my host whether I could wear jeans today. All right, so as Avinash said, I'm the guy who's responsible for embedding artificial intelligence into many of the solutions that people do worldwide. So I'll give you some. I'll do it much more practical way. I'm not going to give any hype or anything around it, whether if it's really worth the investment. So this is something which most people may not have noticed. This is how we used to do traditional software. You gather the requirements, you then go and do a solution and design and some development, validation, testing, and those. But what has changed is the fact that the AI-driven tool development cycle is actually different. Okay? So those things that I have marked in purple on you, and those are not activities that we have. And the most important activity, of course, is the first one upstream. That's the data identification problem, right? So AI, as many of the speakers spoke yesterday, they said, it's all about getting the right data to make sure that you can make it work. But if you don't have the right data, then you have a problem. You just don't have it. So data identification is one of the simplest things that you have to do before you get any value out of it, right? Otherwise, you don't know the data. And if you use the wrong data, you can prove anything. Most of the models that underpin AI are statistical models. And the old saying, statistically, you can prove anything if you have the right data. So basically, you might be going down the wrong track if you don't have the right data. Okay. So you have modeling and the development part of it, and the training, which is different to testing. Remember, we're talking machines, right? We don't understand how exactly is learning. So how does learning actually work? So let's say you're trying to teach a small kid how a newspaper looks like. Trying to teach him that something is a newspaper. You're not going to say, okay, newspaper has got this, these many columns, it looks like this, it can have pictures, etc. You show him a newspaper and say, son, this is a newspaper, okay? And you look at it and say, yeah. Then you show another newspaper, not the same one. Say, son, this is also a newspaper, right? And you show 4 or 5 of them, and then you say, okay, tomorrow morning when the newspaper comes, identify it, right? Now, remember, the newspaper for tomorrow, he would have never seen, right? Because it has not been published yet. So, when he sees the newspaper tomorrow, somehow his brain has seen so much of data regarding the newspapers and said, that looks like a newspaper. Although he's not really confident, he's going to think, Dad, I think this is a newspaper. And I said, yes, son, that's right. So that's reinforcement of learning, right? Where the kid came back and said, I think it's a newspaper, and therefore this ought to be reinforced. And that's the learning process. So training is actually part of that. Whenever you have a machine, you have to teach it how to do it. So many years ago, in 1994, and some 25 years ago, I was working in Houston and in the oil exploration business. That's where I actually started my career. My boss came to me and said, Mike, we have got all this data. We collect tons and tons of data. When we go, when we send these drills into the hole to check whether there's oil or gas, right? Is there anything you can do about it? I said, okay, let me try. And I looked at all the data and started to identify certain rules, and I identified some patterns, and it was a big deal. I worked on it for 3 months, and finally I found a way to use that data to figure out whether it is oil or gas or water. And it was like a breakthrough landmark patent. Right? If you go online and check my name, you'll see that I have a patent in oil exploration. But it was actually data analysis that So data and identification of patterns from data is something that has been there forever. It's not anything new. And we now have come to the next era, our 4.0 era of industrial revolution, and that's where we start to use that. Now, this paradigm shift is very important because without this Okay. So, remember, artificial intelligence is art first, intelligence later. So, literally, quite literally. So, we are now on this mechanism to go and find out where good data is, where bad data is. And you know what happens? When, let's say you want to start a new venture, you want to sell pizzas or something like that. The problem is, most of the artificial intelligence is all about getting the data, identifying a pattern, and then leveraging that to enhance your business, right? Problem is, that data doesn't exist. Because you first visit, you get into the chicken and egg problem, right? So where do you get data from? The original data that you need to get, you have to buy from somewhere, or an industry body has to provide that to you, right? Which is where, when I was listening yesterday to Mr. Yesudas speaking about the food platform, I said, that's a fantastic way in which an industry body could actually drive the collection of data and generalization of their data and then provide it for the members, right? It's actually an excellent way in which you can actually do that. So most of the time we actually don't have real data that is that's actually available readily for you to do anything. And here's the other problem. Let's say, many years ago, there was a US retailer, I'm not allowed to say the name, but you probably figure out the story. So they had two flat quarters of sales. They had a problem. So they fired the CEO, brought in the new CEO, and they said, well, he said, well, we're going to change the way we're going to do business. So these folks had 4 sale events, right? Spring, fall, summer, and winter. And he said, a sale like that doesn't make any sense, right? We're going to scrap all the sales and we're going to do everyday low prices. Right? Now, they had a lot of loyal following who used to come for the sale events and it would drive the sales up and they would have spikes of their sales across 4 quarters. Guess what happened when they got rid of the sales? Suddenly the sales started climbing. So now the company went into a little bit of damage control more and they said, well, here's a way in which we are actually going to provide free haircuts for kids in the stores. So that the idea behind that would be moms will bring the kids and the kids will have free haircut, moms will do the shopping, and our sales will go up. Guess what happened? Well, the moms came to the kids got the free haircut, moms left, right? So they didn't actually get the sale. It was quite easy for them to really realize that would happen if they had done some video intelligence, right? They could have seen the number of people coming with their kids to actually do shopping, and they would have done something like that, right? So it's a question of where data was not really used to make a strategic decision. And the important thing is, anytime you make a strategic decision, the data patterns have suddenly changed. You understand? So when you make a decision, your original data that from which you derive intelligence and rules and everything else has changed. So one very important thing, if you're doing artificial intelligence or if you're doing, let's say, plain old machine learning, change has to be gradual. The abrupt changes you cannot handle with AI. Okay? That's a simple practical tip. Whenever there is a huge change, stop, because your data is set from where you derive that is actually different. Okay. There's a whole bunch of stuff that I have actually put, but the most important thing is you have data, right? And the other one is all these activities that are related around data engineering, data science, how do small businesses and medium-sized businesses actually, the large ones obviously could afford an army of data scientists and come in and do it. How do you actually do that, right? So I'll show you a little bit of this thing, how quickly you can actually start to embed AI within your solution or your application. Okay, so one of the industries in which we have very successfully done AI is actually e-commerce, right? So we have the fashion industry, right? One of the problems in the fashion industry is that people buy things and they are very expensive, probably 2,000, 3,000 euros worth of stuff people would buy, and they'll put it on, they'll say, I don't like it. They go back and return it, right? The moment you return a very high value item, you have a problem. You now created a depreciation in price, and then you do restocking. Sometimes, you return, you bought it in the UK, but it'll actually sell better in France. There's a lot of things that actually happen. But here's the way in which we use AI. We looked at all the patterns of how people buy things and return things. The moment somebody shops, and I won't tell you which customers it is, but the moment somebody shops, the system automatically computes the probability this is going to be a return. So they already know it. Okay? So the moment you bought something online and you think you're the only one who knows it, and it turns out that they already know that you are about to actually return. So returns are one very key thing, and not only that, it will actually predict the number of days in which you will actually return it. It'll say in 5 days, say I will actually return that thing, right? So it's easily possible, and I'll tell you a very simple thing. We are looking at some of the data, what we analyzed, what we found was that when people place their orders after 10 p.m., there is a 15% probability, high probability they'll return it. I don't know. All items bought at night have a higher propensity of being returned. Just the data, that's for that retailer, that's how it's actually shown. Now, in the consumer electronics, the other issue is sometimes people would go in, check all the items in the showroom, then would say, oh, I know what, I'm just clearly I'm heading out. And that was their main problem, that people would not go into the showrooms and therefore would not buy things from their stores, but would try to take things online and then just drop off, abandon it. Right? So one of the things we said was, okay, looking at all the carts that were abandoned, we looked at the items and the people who abandoned it. And now, when you start adding items to a cart, the system goes back and computes what is the probability that this will actually be checked out, right? So when the probability goes above a certain level, and it says, okay, we are going to give, we are not going to make any nice offers. If the probability goes less, it starts popping up saying, hey, how about some free shipping for you, right? It's a deal. You want to check out now in the next 5 minutes, right? All right. So these are all different things. So the one main question is in the food services industry, which is where a lot of the way in which that I actually work now, trying to do some of the disruptive mistakes. And I'll tell you one very important disruption that I've seen in the food service industry. And if you go to Silicon Valley, you'll actually see the amount of money that is being pumped into food service applications, right? And the reason, and because of that, you now have the kitchen, which is where food is prepared, processed, whatever, right? And where food is experienced, and food is the only thing that's about 5 senses, right? So where it is actually experienced, the dining room, they've actually got separated, right? Now it's possible for you to take a kitchen and then scale it to 50 times the size of Amazon, and then deliver food to wherever you want at much lower prices, right? So that becomes the very large kitchens now will start to look more like actual manufacturing units as opposed to just little mom and pop shops, right? So that's the disruption, which just like Uber that we saw in the past, the changes that all the Silicon Valley folks will actually tell you is that that's the disruption they're waiting for, the separation of the kitchen and the dining room, right? So the dining room can be some place where you just want to have a dining hall and order food from wherever, and you and your friends go sit down there, book a table, and you get food from 4 or 5 different places. Everybody gets their choice, right? Otherwise, if you went to a Mexican restaurant or a Chinese restaurant, you will have a problem. So that's the next disruption that we believe that is actually coming. In fact, I'll show you something related to that. There are a lot of other things that maybe not so much of other things. So how do you take AI and how do you downsize it so that small businesses, the food service industry actually benefits from that? That's the thing. So here, what I have said that was just from a thought. Food delivery happens, it's already there. It's around the world, right? Everywhere you go, you will actually find that. But what you don't have is, so the delivery fees are usually on a per delivery basis, right? But that's not the most efficient way of actually doing it. If you have heard about Costco in the US or Amazon Prime, right? What you've actually got to that is you've got a certain basic entrance fee, member fee, right? $110 or something like that. And because you spend this upfront $110, people keep buying more and more, and it becomes more like free frenzy. You keep buying thousands of dollars worth of stuff because you spent this membership fee, and they want to maximize it, right? So we don't have that model yet, but we will. I'm very, very sure of it, and that's what we're waiting for, right? So that's where I said annual fee for delivery, like maybe $200 per year for all food delivery, whatever food you want, right? And then suddenly, so because I paid for the delivery, now I'm going to order it every night, right? That's all. So large kitchens, this thing, and different dining experiences, things like that, right? But there are challenges. There are lots of challenges. The problem with trying to use AI into a small business is that whereas the business may be small, the data needs are not small. Okay? So although it is small business you're talking about, it doesn't mean that you can do with less data. And definitely you cannot do with fake data. There is no way in which you will get any realistic results if you use fake data. You have to use realistic data, and you have to actually get sufficient quantity of data. How do you know that? How do you know that you have enough data and you have all the data that is necessary? That's where, remember, I think it was Mr. Luther who actually said that. Engage the data scientist. Every small business should, even if it is small amount of time, you should still do that. Okay? Very valuable, very, very practical advice. Okay, so one of those things is the customization of solutions. So let me actually talk a little bit about maybe two sentences about how we see software and how we see data, right? Software is a representation of the technology that you use, right? And data is a representation of the business. So within, and as my mentor once told me, he said, and much older than when I started, I was like, remember there are only two things in every business. You have assets and you have data, okay? So remember, all you have is those two. And how do you leverage those assets, how you utilize them, is up to you to do it. And data drives that, okay? And so if you want to really use it, every business is unique in its eventual delivery, and every business is also got general rules, right? So there are things that you can derive out of, like what are the regulations that control it, and that's you can just derive from the data. And what are the most important KPIs that you need to worry about if you are delivering pizza? Right? Is that the temperature? Is that the softness? Is that the look and feel of it? You can actually get a picture of your pizza. And there are applications that shows you, here is your pizza being delivered. It should look like this. So they'll give you a sample picture so that if it doesn't look like this, reject that pizza on spot, right? All right. Now, let me just talk about some examples of this thing in the manufacturing. I had not gone too much into it, but here it is. One of the places where we find AI is very valuable is actually deciding the quality control. How frequently should you sample, right? Now, typically you will realize that you should sample, they'll tell you every 100,000 samples should be taken, checked, destroyed, whatever, right? Or sent to the lab. But that 100,000 is just a random number. But it could be that in the morning 100,000 makes sense, but in the afternoon, when the shift is actually running better, you actually don't need to really plan. And you can predict where your failures are. And I think it was Aman saying, who actually presented yesterday. I was actually watching it in TV, and he was saying that yes, there is actually predictive failure that you would actually pull up. Let me just try and wrap it up quickly. So here's a prototype. So we have a tool that says Embedded Business AI Framework, right? It actually is just an open framework. Use it to enhance your AI into the thing. So I used it just for a simple app that would take things like you can type it, you can use natural language, you can use search, etc., etc. What it provides is not so much this part that is the interesting piece, right? Because this you can have it on an app, you can have it you can have it work it from home, or you can do anything else. And that is probably the interesting part, because it can do things like you can predict the demand for tomorrow. So you have a dish that you don't know what the demand is, but you can predict it, right? So that way, once you predict the demand for tomorrow, you know how much stock is actually going to get consumed. It also can give you capabilities like you can just let Watson read the recipe, pull out the ingredients, and then it knows the quantity, and it will connect it to the stock. So there's a little bit of integration involved, but you can actually do that, right? So, and you can say today's guests come back to tomorrow's guest estimate. This is something three of my colleagues, Sheffield, and it's been hooked up in a few days. So just to show you how easy it is to really use this EDA. So, and let me see whether if I can run this video quickly.
This demo showcases Watson Embedded Business AI Framework for Food and Beverages Industry. Watson Restaurant Assistant is an intuitive user interface to help customers ease the process of ordering food and beverages according to their preferences and tastes. Watson's natural language-based search narrows down the menu for the user to make a quick choice. Watson keeps track of a customer's order history and helps the customer navigate at a much faster pace when placing additional orders. Watson Restaurant Assistant takes the customer to the checkout screen with just a few clicks. Watson Restaurant Assistant will also assist the inventory manager to predict the demand for an item in the future. Automatic data collection occurs by uploading recipes or invoices, and this serves as data for unsupervised machine learning. Continuous machine learning takes place when actual data is validated against the demand prediction. The most frequently asked questions are in the form of buttons. This would ease the process for the inventory manager to get the daily estimate.
Okay, so that's just to give you an example of a simple app you can just hook up and use the backend to say what's the demand like, right? So just to make it easier. And even as I'm not saying it's ready for a small mom and pop shop, but medium-sized businesses should be able to actually do that. And that's it.